We're ready to talk about ellipses. For an ellipse, you're going to let A be bigger than B. If you have an ellipse that goes this way, I didn't quite connect there. We get the idea. It's long, but not very tall. That ellipse will have the equation x minus h squared over a squared plus y minus k squared over b squared is 1. And these numbers, h, k, a, and b, are all something important. What's hk? Hk gives you the center. Just like it did for a circle. So center is right around here somewhere. Anybody know what the A number is? A is the distance from the center to a vertex, either one. That distance is A. A is the distance from the center to a vertex. This point over here is called a vertex. And this one over here is also called a vertex. Well, if that's A, then what's B?
One of the sides.
What do you mean, one of the sides? It's an ellipse. It only has one side.
Like the vertical. Perpendicular. Yeah.
B is that distance. It's the distance from the center to this point. This point is called a covertex, as is this point down here. So ellipses have vertices and covertices. Now, somewhere within this ellipse are the 2 points, which are the foci. So you might have a focus here somewhere, and a focus over here somewhere. So remember, that's the 2 points where I taped down my wire yesterday, and then from the wire you can draw the circle, or draw the ellipse. The distance from the center to a vertex, from the center to a focus, that distance is called C. C is the distance from center to foci. And it turns out there's a nice relationship between all these letters. C squared turns out to be a squared minus b squared. Almost looks like a famous theorem. Almost looks like Pythagorean, except it's got a minus instead of a plus. How do things change if your ellipse is tall and skinny?
B's greater than A.
Well, notice that I said A is always going to be bigger than B. So when you're tall and skinny, you're going to have x minus h squared over b squared plus y minus k squared over a squared. So you have the right idea. The right idea is you can tell which way it goes by which one is divided by a bigger number. If the y is divided by the bigger number, it's tall and skinny. When x is divided by the bigger number, it's wide and short. And then the rest of the things are exactly the same. A is still the distance from the center to the vertex. The only thing is the vertex now is up or down. This has a name too. What's this long length called? That's called the major axis. And the short length this way? The minor. So when you go up and down, your major axis is now this direction, and your minor axis would be that direction. B is still the distance from the center to a covertex, and C is still the distance from the center to one of the two foci. questions on that? All right, so what could happen? Well, I could give you some information. I could say, I want to know the equation of the ellipse. This ellipse is going to have a center. What do you want for your center? 2, 4. A vertex. Where do you want your vertex to be? 2, 8. Where do you want your focus to be?
2, 6.
2, 6 would work. Very good. Okay, so it sometimes helps to draw yourself a little picture here. Our center is at 2, 4. And then our vertex was at 2, 8. So why did it make sense to put the focus at 2, 6?
So the focus is in between.
The focus has to be in between the center and the vertex. And so you chose to put it halfway in between. I suppose that'll work. 2, 6. So this is a ellipse, which is tall and skinny. We're going to have x minus h squared plus y minus k squared. This one gets divided by b squared. That one gets divided by a squared equals 1. Okay, what's a? A is how much? 4. Why is a 4? Distance from center to vertex. The distance from 2, 4 to 2, 8 is a distance of 4. What's b? 2. I don't think so. Could be, but I don't think so. Well, let's skip that one. Let's come back to that one. What's the point HK? 2, 4. That's the center. So HK is 2. All right. I don't think they gave us enough information to directly know B. I think we're going to have to do some work to figure out B. I do think they gave us enough information to figure out C. What's C? Why is C 2?
From the center to the focus.
It's the distance from the center to the focus. That's a distance of 2. I think what we're going to have to do is use C squared equals A squared minus B squared to figure out B. And that happens quite often. It's actually kind of rare if you were to be given information about the vertex and information about the covertex. Usually you're given information about vertex and focus. And so quite often you have to use that formula. 4 equals 16 minus b squared. So b squared is 12. Here's my answer. My answer is x minus 2 squared over 12 plus y minus 4 squared over 16 equals 1. People will usually ask me, how come you didn't write b equals the square root of 12?
Big square.
I really don't need b, I really need b squared, so I might as well just leave it that way. B squared is the number I really need, so I might as well just leave it as b squared equals 12 and plug it in right there.
Where does the 1 come from?
Where does the 1 come from? This one right here?
Yeah.
Again, it comes from deriving the equation of the circle, or I'm sorry, not the circle, the ellipse. To derive the equation, you pick a point here called x comma y, and then you have to find this distance, and then you have to find that distance, and you add them together, and it has to be a certain value. If you pick any other point, such as this one, then it has to be the exact same distance, because that's the definition. If you take the distance from any point and add them together, you get the length of half the length of the major axis. And so when you work out that formula, you get something that usually actually works out to be some number. I don't know what number to use because we've used lots of letters. Maybe you get x minus h squared times some number, I'll call it p, plus some number times y minus k squared, and usually you get a number over there, r squared. And so what happens is, the way these are always traditionally written is you divide by the r squared, and then p over r squared, you call that one b squared. And q over r squared, you call that one a squared. This is just the traditional way that it's written. And it's written this way because the b and the a turn out to be those important numbers. Other questions? All right, how about if I gave you, steal one out of the book here so it comes out nice. Nine x squared plus 4y squared plus 36x minus 24y plus 36 equals 0. If I were to give you that equation, you should quickly recognize that that is the equation of an ellipse. How do I look at that equation and recognize that that's an ellipse?
Coefficients on the highest power.
It has both an x squared and a y squared. The coefficients are different. Since the coefficients are different, it's not a circle. When both of these coefficients are positive, that's when you get an ellipse. What's going to happen if one is positive and one is negative? You're going to get the third conic section, the one we haven't talked about yet. There's parabolas, there's ellipses, there's hyperbolas. If you have both of these squared, one of them has a positive coefficient, one of them has a negative coefficient, that's when you get your hyperbola. Okay? What if this was a 9x squared and that was a 9y squared?
Just be a circle.
Then it would be a circle. If the coefficients match exactly, it's a circle. One positive, one negative, it's a hyperbola. Different coefficients, both positive, it's an ellipse. What if they're both negative? Then you multiply the whole equation by -1, and now they're both positive. So if they're both negative, it's also, if both negative and different, it's also an ellipse. Okay, so since we know that's an ellipse, I want you to tell me all the important information. I want to know the center. I want to know the focus. I want to know the other focus. I want to know the vertex. I want to know the other vertex. I want to know the co-vertex, and I want to know the other co-vertex. So I want to know 7 things. What do? You're going to have to complete the squares for both the x and the y. That's exactly correct. Because you need to write it in that form that has the parenthesis x minus h squared. Okay, so I'm going to rewrite this. This is 9x squared plus 36x plus 4y squared minus 24y equals negative 36. Group the x's together, group the y's together, and move that 36 over to the other side because I didn't need it for now. All right, how do I complete the square on the x's?
Factor out of 9.
Y factor out of 9.
Makes it easier.
Not only does it make it easier, it makes it correct. In order to complete the square, that first number has to be the number 1. So you've got to factor out of 9, and you write that as x squared plus 4x. And I'll leave some room. In a minute, we'll add our magic number in there. I have to do the exact same thing on the y's, except I factor out a 4. Y squared minus 6y, leave some space, equals negative 36. Okay, so now I can put in my magic number. What's my magic number for the x's? 4. If I do a plus 4 on the left-hand side, I have to do a plus 36 on the other side. Most people would say a plus 4. Why is it a plus 36? Because it's inside that bracket, isn't it? I really did 9 times 4, which is 36 over here. Same thing with this one. The magic number here is 9. 9 times 4 is I can add 36 again. 36 seems to be a popular number in this problem. Okay. That's 9 times x plus 2 squared plus 4 times y minus 3 squared equals 36. Almost in the right form, but not quite. What do I need to do next? I need this to be the number 1 over here, so I divide by 36. What's 9 divided by 36?
1/4.
1/4?
Yeah.
That's right. So I'm going to write this as x plus 2 squared over 4. What's 4 divided by 36? 1/9. So that's y minus 3 squared over 9 equals 1. Is this parabola wide and short? Or parabola, I'm sorry. Is this ellipse wide and short? Or is it tall and skinny? Tall and skinny. How do you know it's tall and skinny? The bigger number is under the y. All right. So tell me, what's the center?
-2, 3.
Negative 2, 3. How about the vertices?
-2, 6 and -2, 0.
Negative 2, 6 and negative 2, 0. Excellent. How did you get negative 2, 6 and negative 2, 0?
The bigger number is going to be the a squared on bottom, so that's the 9, and then the a would be 3, and then you just add and subtract.
Perfect. You got your center at negative 2, 3. Your a number is 3. So to find your vertices, you start at your center, you go up 3. That'll be negative 2, 6. Oh boy, scaling is terrible. And then you go down 3. That'll be negative 2, 0. Okay. How about the co-vertices?
-4, 3 and 0, 0, 3.
Very good. Same deal. Your smaller number is 2 squared. So you're going to start here. You're going to go 2 to the right, which puts you at 0, 3. And you're going to go 2 to the left, which puts you at negative 4, 3. So because my scaling is bad, this does not look like an ellipse, which is tall and skinny, but it's supposed to be. Bad scaling. Negative 4, 3, and 0, 3. And finally, How about the foci? Well, to find the foci, I need to start at the center and go up a distance of c and go down a distance of c, which means I need to find c. C squared is a squared minus b squared. That's 9 minus 4. So c is the square root of 5. So here's how I would write my answer for foci. I have to go up the square root of 5 and down the square root of 5. So I would write it as -2, comma, 3 plus and minus square root of 5. That's how I would write them. If you want to write them separately, that's fine. You can write -2, comma, 3 plus the square root of 5, and then -2, comma, 3 minus the square root of 5 if you want. I prefer to just write them in one term. Questions on that?
Could we write like the vertices and the co-vertices in the same way?
Absolutely, if you wanted to. So you could write your vertices as -2, comma, 3 plus and minus 3. Kind of the tradition is if the numbers are all integers, we don't write it that way. But if you wanted to, I'm not going to mark it wrong. You've clearly shown you understand how to find the vertices, and that's fine with me. Typically, we only do that when we have square roots. But. Other questions? All right. I want an ellipse. I want its center to be at the origin, kind of like that. I want its major axis to go horizontally. So how far out do you want it to go? Where do you want your vertex? 5? So we're going to have a vertex at 5, 0, and at -5, 0. And how about your co-vertex? Where do you want your co-vertex? 3, 0, 3, 0, -3. So here's this ellipse. Looks like so. I want to find the area of that ellipse. First off, what's this equation? X squared over 25. Why 25? It's a squared plus y squared over 9 equals 1. How do you find the area of an object? Back to Calc 1. You integrate it. But I think I'm going to be clever, somewhat clever anyway. I'm just going to find the area in the first quadrant, and then I'll take my whole answer and I'll multiply it by 4. So I'm going to have 4 times the integral. X would go from 0 to 5 of what? Well, I think what I need to do is I think I need to take this equation and get y all by itself. So y squared over 9 is 1 minus x squared over 25. So y is 9 minus 9x squared over 25 squared square root of that whole thing. Okay, so that's the square root of 9 minus 9x squared over 25 dx. Remember, to find the area we integrate, we just take the top. The top is the curve minus the bottom, but for this one, since I'm just using the first quadrant, the bottom is the axis.
If you were to do plus and minus, the whole thing would only be times 2?
Yes, if I were to do the top half and have the positive square root minus the bottom half, I'd have the negative square root. Then I'd be finding half of it, and I'd have to multiply by 2. Correct. How do you integrate that?
The trig sub problem.
And what tells you that's a trig sub problem?
You're subtracting things under and square root.
You have a square root combined with a square. That's almost always a trig substitution problem. So a little exciting review of trig sub today. All right, well, I'm going to make it slightly easier. I'm going to pull the 9 out. So that's 4 times the integral from 0 to 5. If I factor a 9 out, I can then do the square root of 9. The square root of 9 is 3. So that's 3 square root of 1 minus x squared over 25 dx. Now what? Bring the 3 out. Okay, 4 times 3 is 12. Yeah. It's not wrong. I was hoping for something a little more. We can't do a u sub because I would have to let u be the x squared, and then du I would need a 2x out here. I don't have an x out here.
Could you make it x over 5 and square it? I don't know. It would be like u squared or something.
Okay, that might make things a little bit easier. I see what you're saying. He wants to let u be x over 5, which means u squared will be x squared over 25, and du will be 1/5 dx, which means we'll need to multiply by a 5. Okay, so this is going to be 4 times 3 times, I'm going to need a 5 from here, 5. Integral, I'll come back and I'll fix my numbers in a minute. Square root of 1 minus u squared du. And now, what are my numbers? Well, when x is 0, u is 0. And when x is 5, 5 over 5 is 1. Okay. We're getting there. Now what? What was our substitution when we had a minus something squared? A sine theta. So u is going to be just sine theta, because a is the number 1. Which is going to give us 1 minus u squared is going to be the square root of 1 minus sine squared theta. And 1 minus sine squared is cosine squared, and the square root of cosine squared is cosine. And then finally du is, what's the derivative of sine? Cosine theta d theta. So, moving along here, we have 4 times 3 times 5 integral This square root turned out to be a cosine. This du turned out to be a cosine. Cosine times cosine is cosine squared, theta d theta. And now we got to change our numbers again. If u is 0, sine of what gives you 0? 0. Conversely, when u is 1, sine of what gives you 1? Pi over 2. Okay. How do you integrate cosine squared? Power reduction formula. Okay, so what do you get when you do power reduction formula? Four times 3 times 5, the integral 0 to pi over 2 of 1/2 minus 1/2 cosine of 2 theta d theta. Isn't it plus? Your card is always right. Four times 3 times 5 times 1/2 theta plus 1/4 sine of 2 theta evaluated from 0 to pi over 2. Four times 3 times 5 times, I plug pi over 2 in. What's 1/2 times pi over 2? That's pi over 4. I plug pi over 2 in. What's 2 times pi over 2? Pi. What's sine of pi? 0. Minus, I plug 0 in. 0. 4 times 3 times 5 times pi over 4. Questions on that?
Wait, we're done? Don't we have to go back because we made 2 substitutions? Or?
No, we don't have to go back because we made 2 substitutions. Why not? Because I changed my numbers at each step. Since I changed my numbers at each step, I'm in good shape. I think I'm done. That's not the answer I thought I was supposed to get. It's kind of a nice answer. Okay. Notice I can reduce the 4's, and my answer turns out to be pi times 3 times 5. What was special about the numbers 3 and 5 in this problem?
Vertex and co-vertex.
5 was the length of the vertex, 3 was the length of the co-vertex. 5 times 3 times 5. No, that's where that original 4 was from. That's where that 4 came from, and that 4 came out. So if you have, was there anything special about the number 5 and 3? Well, but we picked them randomly, didn't we? We just picked those numbers 5 and 3. So will it always come out that way? If I had picked 7 and 2 instead, would I get pi times 7 times 2?
Pretty nice.
I would have, actually. It's the way it always works out.
If it's 0, right?
It doesn't matter.
Would it matter if it's not centered at the origin?
Areas.
If I were to take this and just slide it over and do a fixed transformation, the area would be the same, wouldn't it? So, I think what we just discovered is a formula for finding the area of an ellipse. What's the formula for area of an ellipse?
AB pi.
AB pi. It's easy when you get the final answer. Not so easy to get there, was it? Trig sub, powers of trig.
Well, if you don't ask us how we did it, we could just, like, what's the area of this ellipse? Oh, 14 pi.
Yeah.
Well, we don't have to show you anything.
You don't anymore. You don't anymore because I showed you how to get the formula for the area.
That mathematician must have been so happy when they discovered that.
Finally a shortcut.
How many like trials do you have to do before you know that there's absolutely nothing it won't work on?
I don't know.
You got a lot of free time back then. They probably didn't think about that.
Yeah, they didn't have like TVs and cell phones, and they had nothing to do, sit around by candlelight and do their math homework, you know? Good times. All right, the last thing we need to talk about is hyperbola. Hyperbolas come in two forms. We have x minus h squared over a squared minus y minus k squared over b squared equals 1. Looks almost exactly like an ellipse. The only difference is it's got a subtraction. If the x has the positive value, then your ellipse will open left and right, like so. And you might recall with, did I call it an ellipse? I meant hyperbola. You might recall with hyperbolas that hyperbolas have asymptotes, like so. These asymptotes will cross right at the center. Mine doesn't look like that's happening, but that's where they should cross. So where this point crosses, this is called the center, and that's HK. A is still the distance from the center to a vertex. That distance is still called A. Now, unfortunately, B doesn't have a whole lot of meaning. B is a distance from here to some point up there, but it doesn't have a whole lot of meaning because it doesn't touch the graph. There is also the point C, which is one of the foci. C is the distance from the center to a foci. And then the relationship turns out to be exactly the same as the Pythagorean theorem. C squared equals A squared plus B squared. The equation of your asymptotes in this case is going to be y equals k plus and minus b over a times x minus h. So you have one with positive slope, that's the plus b over a, and one with negative slope, that's the negative b over a. The other possibility, of course, is you could have y minus k squared over a squared plus x minus h squared, minus x minus h squared over b squared equals 1. And these will open up and down. And then everything else is the same. You have your center, you have your vertices, you have your foci. The only difference is the formula for the asymptotes is slightly different. Y equals k plus and minus a over b times x minus h.
So A and B are fixed in their like arrangement formula, right?
A and B are
that changes now?
correct. A and B are fixed. A is always the one that goes with the positive term. So A is here with the x's, A is here with the y's. So A always goes with the positive one, B always goes with the negative one. Size doesn't matter. It doesn't matter which one is bigger. Which matters is which one is positive and which one is negative. That tells you the direction.
What is B in the graph? Well, like,
B doesn't make a whole lot of sense. There's a point this distance away called B, and if you draw this box that has length A and height B, you can use that box to prove the formula that c squared equals a squared plus b squared. But B in itself really doesn't have a whole lot of meaning because B is not a point that ends up sitting on the graph. So, some distance there. All right, so the problems for hyperbolas are going to look a lot like they did for ellipses. Except you're going to have a minus sign in there. So let's say you had y squared minus 16x squared plus 64x minus 208 equals 0. You should look at that equation and right away you should recognize that's a hyperbola. What tells you right away that that thing's a hyperbola?
You have different values and signs on the x squared and y squared.
You have both an x squared and a y squared, and they have different signs. They could be the same. If this was a y squared and that was a minus x squared, it would still be a hyperbola, as long as one is positive, one is negative. Same question I asked in the last one when dealing with an ellipse. I want you to tell me the center, I want you to tell me the vertices, and I want you to tell me the foci. We don't have co-vertices for a hyperbola. What do you have to do?
Complete the square for the x's.
Complete the square for the x's. You don't have to complete the squares for the y's because it's just a y squared. So we're going to write this as y squared minus. In order to complete the square on the x's, I'm going to have to factor out the 16, aren't I? So I factor out the 16. What's left inside? X squared minus 4x. Excellent. It has to be a minus 4x because I need negative 16 times negative 4 to give me the positive 64. Then I can add my magic number. My magic number is a 4. And so what number do I have to put on the right-hand side to balance that out? A minus 64. Again, don't fall for that trap. Just because you put a 4 here doesn't mean you put a 4 there, because this 4 is being multiplied by that negative 16. All right, so we have y squared minus 16 times x minus 2 squared is 144. I divide by the 144, y squared over 144 minus x minus 2 squared over 9 equals 1. Where's the center? Two zero. What can you tell me about my vertices? Are they higher and lower, or lefter and righter? Higher and lower. How do you know they're higher and lower? Because the y is the 1 squared. How much higher or lower? 12, because 12 squared is 144. So I start at 2, 0, and I go up 12. That's 2 comma 12. And I go down 12. That's 2 comma negative 12. Finally, I would ask you about the foci. And again, for the foci, I need to know the c number. C squared is a squared plus b squared for a hyperbola. So c squared is 144 plus 9, which is 153. So c is 153 square root. Again, my foci go up and down from my center. So I would write my foci as 2 comma plus or minus square root of 153. Questions on any of that?
It doesn't matter that the x is the right term, the y is the left term. Or is that how the...
It does not matter. What matters is that the y is the positive one and the x is the one with the negative in front of it. So that tells me that the hyperbola goes that direction, and it also tells me that this number is a and this number is b. A always goes with the positive one, B always goes with the negative one. Okay? Nick?
Is the actual shape of the hyperbola stuff in between the curves? Like
the hyperbola comes in two pieces. It's got that piece and that piece.
As I was like thinking of the building that you showed us yesterday, it was like kind of capturing the stuff that was...
Right, so the building, the shape of the building would be take this hyperbola and spin it around the y-axis. And so it was this outside curve of the building was in the shape of the hyperbola. Okay? You know, I just thought of something. We made it life hard on ourselves. When we got to right here, we should have just said the square root of 1 minus u squared. That's a circle with radius 1. Since I have the positive part and I'm only integrating from 0 to 1, I just have the area of the circle in the first quadrant. How do you find the area of a circle? Pi r squared. So pi is pi and r squared would have been 1. So that would have just been pi. Would have been a lot easier to do it that way. Except it's only a quarter of the circle, so we would have had to divide by 4. So when we integrate this, we should get pi over 4. So had we been thinking a little bit, we could have avoided the trig substitution, avoided the power reduction, and just said, oh, that's pi over 4. Plugged it right in. We weren't thinking, were we? And I forgot about it. And that's a habit you get into. You see this problem and you say, trig substitution. And you forget about everything else, you get your blinders on. We could have said that's just 1/4 of the area of a circle with radius 1, pi over 4. Would have been a lot easier.